Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Part 22 with matplotlib tutorial. So in this tutorial we will discuss about how to working with figures using matplotlib. In this chapter, we will cover following 7 things as you can see here. Alright, so first we will discuss about compositing multiple figures in matplotlib. So let's get started. When examining some data, we might want to see several aspects of it at once. For instance, with population statistics data from one country, we would like to see the male or female age pyramid, the wealth repartition, and the population size per year as 3 distinct graphics. Matplotlib offers the possibility to composite several figures together. Since version 1.2, the API for this is really convenient. In this recipe, we are going to see how to compose several figures together. Let's see the example. Now see here, the idea behind pyplot subplot2 grid is to define a grid of R rows and C columns. Then, we can render a figure to a rectangular patch of that grid. The pyplot subplot2 grid function has 4 parameters. Number 1, the first parameter is the number of rows and columns of the grid, passed as a tuple. If we want a grid of R rows and C columns, we would pass R and C. Number 2, the second parameter is a coordinate in the grid, in rows and columns, also passed as a tuple. Number 3, the optional parameter rowspan defines how many rows the figure will span. Number 4, the optional parameter colspan defines how many columns the figure will span. Once pyplot subplot2 grid is called, further calls to pyplot will define a figure within the specified rectangular area. To render another figure in another area, we call pyplo subplot2 grid again. In the example script, we define a 2x4 grid. The 2 top figures span over 1 column and 3 rows, thus filling almost 1 full column each. The third figure spans over 2 columns but only 1 row, filling the bottom row. Once all the figures are described, we then call pyplot tight layout function. This command asks matplotlib to pack all the figures so that none of them overlap each other. Now we will see another example. We have seen pyplot_title add a title to a figure. In the following example, we are using pyplot_title to give a title to each subfigure. So now you can see here, the pyplot_title function gives a title for one subfigure. If we need one title for the whole graphic, we should use pyplot_subtitle, where subtitle stands for superior title. Now we will see an alternative way to composite figures. The subplot mechanism introduced here is fairly general, it allows us to create complex layouts. If we just need to have a couple of figures in one row or one column, we can use simpler code. Let's see here, the pyplot subplot function takes two optional parameters, n columns and n rows, and will return a figure object with n columns into n rows instances of axes. The axes instances are laid out in a grid of n columns by n rows. This makes grid layouts very easy to create. Now we will know about how to scaling both the axes equally. By default, matplotlib will use a different scale for both the axes of a figure. In this recipe, we are going to see how to use the same scale for the two axes of a figure. Now you can see here, in this example, we display an ellipse where the major axis is twice the length of the minor axis. Indeed, the rendered ellipse follows those proportions. Now we'll see how to setting an axis range. By default, matplotlib will find the minimum and maximum of your data on both axes and use this as the range to plot your data. However, it is sometimes preferable to manually set this range, to get a better view of the data's extrema. In this recipe, we are going to see how to set an axis range. Now see here, the pyplot xlim and pyplot ylim parameters allow us to control the range of the x-axis and y-axis respectively. These parameters are the maximum and minimum values. Now we'll see how to setting the aspect ratio. When preparing figures for a journal publication or a website, one might need a figure that has one specific aspect ratio. In this recipe, we are going to see how to control the aspect ratio of a figure. Now see here, we use the pyplotFigure function, which creates a new figure instance. A figure object represents a figure as a whole. Usually, this object is created implicitly, behind the scenes. However, by creating the object explicitly, we can control various aspects of a figure, including its aspect ratio. The figSize parameter allows us to specify its size. In this example, we set the horizontal size as 4 times the vertical size, giving it a 4:1 aspect ratio. Alright, now we will see how to inserting subfigures. Inserting a small, embedded figure can be helpful in showing a detail of a figure, or more generally, to emphasize a particular part of a graphic. In this recipe, we are going to see how to insert a subfigure into a figure. Matplotlib allows us to create subregions in any part of a figure, and assign a figure to that subregion. We start by creating a subregion on the figure as follows: sub-axis equals PLT axis, the region is in figure-wise coordinates, that is, 0, 0, is the bottom left corner and 1, 1, is the top right corner of the overall figure. The subregion is defined by 4 values, the coordinates of the bottom left corner of the region and its dimensions. Once the subregion is defined, we have an axis instance in which we create a figure. Then, we need to call pyplotSetP on our axis instance as follows: pltSetP, sub-axis. Note that there is no limit on how many subregions you can create. Now we will know about how to using a logarithmic scale. When visualizing data that varies across a very wide range, a logarithmic scale allows us to visualize variations that would otherwise be barely visible. In this recipe, we are going to show you how to manipulate the scaling system of a figure. There are several ways to set up a logarithmic scale. The way it is done here works for any kind of figure and not only curve plots. In this example, we set up a logarithmic scale that will apply to all plot elements. In this example, we display three functions, with the y-axis following a logarithmic scale. All the work is done by pyploty_scale, where we pass log to specify the type of scale we wish to have. Likewise, we would use plot_x_scale to achieve the same result on the x-axis. A log-log plot can be created quite simply, as follows: plt.x_scale, log, and plt.y_scale, log. The logarithm base is 10 by default, but it can be changed with the optional parameters base x and base y. Now we will know about one last thing, how to using polar coordinates. Some phenomenon are of an angular nature. An example would be the power of a loudspeaker depending on the angle we measure it from. Polar coordinates are a natural choice to represent such data. Also, cyclic data such as annual or daily statistics can be conveniently plotted in polar coordinates. In this recipe, we are going to see how to work with polar coordinates. Alright, as we have seen before, pyplot_axis explicitly creates an axis instance, which allows some custom settings. Simply using the optional polar parameter will set up a polar projection. Note how the legend adapts to the projection. Now we will see another example. Plotting curves is maybe the most common usage for polar projections. However, we can use any other kinds of plots, such as bar charts, and display shapes. For instance, using polar projections and polygons, you can make a radar plot. Use the following code to do so. Sorry, here we need to import the patches module. Alright, now you can see the output. Note that the coordinates for the polygon are angles and distances to the origin. We do not need to perform explicit conversions from polar to Cartesian coordinates. As you can see here. Alright, so friends, our today's video was up to this. Thanks for watching the video, see you in the next video. Please subscribe our channel and don't forget to like and share the video. Thank you.